discuss sequence of function as a review. We all of us know when sequence of function pointwise convergent, uniformly convergent, all condition of sequence of function I have discussed in my previous video. If you don't see my previous video, first see the playlist of sequence of function from first to last. At first see those videos, then today's video would be so easy. Actually today I have discussed sequence of function as a review. At first, as a review, today I will discuss two examples of sequence of function. One example, fnx equal to 1 over 1 plus nx, where x lies between open interval 0 to 1. And another example, gnx equal to x over 1 plus nx, where also x lies between open interval 0 to 1. I will check, is this two function be uniformly convergent? Have you understood how we have to solve? How we have to solve this question? All conditions I have discussed in my previous video elaborately. Today I have picked more example as a just review. Our first example, this sequence of function. At first think oneself, which condition will applicable to check uniform continuous of this sequence of function. Obviously this sequence of function converges to when x belongs to 0, 1, converges to the function fx equal to 0, because limit n tends to infinity 1 over 1 plus nx equal to 0. That means this sequence of function pointwise convergent to the function fx equal to 0. Now we will check, is this convergence is uniform convergence? For this used just definition. As a review, just recall the definition of uniform convergence. All of us know a sequence of function fnx where n equal to 1, 2, 3 up to so on is said to be uniformly convergent to the function f for a set E of values of x if for each epsilon greater than 0 and a positive integer capital N exists such that absolute value of fnx minus fx less than epsilon, strictly less than epsilon, and this is true for each epsilon greater than 0, where for all n greater than equal to some stage, means some positive integer capital N, and x obviously lies between interval, and this is true for each epsilon greater than 0. I have discussed in my previous video elaborately this part and all picture clearly. Today I have just as a review I have indicate this definition again, and another alternative definition is we can define a uniform convergence of sequence of function as follows. A sequence of function fnx where n equal to 1, 2, 3 up to so on is said to be converges uniformly if and only if limit n tends to infinity supremum x belongs to E, absolute value of fnx minus fx equal to 0. That imply from this expression supremum x belongs to E, absolute value of fnx minus fx tends to 0, and this is true as n tends to infinity. For this, pick one particular epsilon, consider epsilon equal to half, then absolute value of fnx minus fx would be, obviously for uniform convergence this would be less than epsilon, and this is true for n greater than equal to big N, and for all x belongs to, here the open interval 0 1. That means just put the value here, the fnx is 1 over 1 plus nx minus 0 less than half, means here I have considered epsilon. This is true for all n greater than equal to big N and for all x belongs to open interval 0 1. Since this is true for all n greater than equal to big N, therefore we can just put this value capital N here, then 1 over 1 plus capital Nx minus 0 would be less than half. This is true for all n greater than equal to, this is true for all x greater than belongs to open interval 0 1. That means that implies 1 over 1 plus capital Nx strictly less than half, and this is true for all x belongs to open interval 0 1. Have you understood? Since this relation is true for all x belongs to open interval 0 1, then we can apply limit x tends to 0 plus here. Then this would be 1 over 1 plus nx, which, and if we put that value, then this value would be 1. But here for uniform convergence I have considered epsilon equal to half. That means here the relation, this relation always less than half, but I have got here 1 less than half. This is cannot possible. So for this particular epsilon, this function be not uniform convergent. But definition of uniform convergence is of function uniform convergent for each epsilon greater than 0. Okay? So this sequence of function be not uniform convergent on the interval x belongs to open interval 0 1. I hope my all viewers have understood this definition. Again, as a review, actually the picture of uniform convergence is, after some stage all fn lies between the neighborhood fx minus epsilon and fx plus epsilon, and this is true for all n greater than equal to capital N and for all x belongs to the interval. This picture I have discussed in my previous video, and this type of question also I have discussed this video. So if you don't see my previous video, at first go my playlist of my channel, then you will see one playlist about sequence of function, and in playlist have all videos of sequence of function. At first see this video, then today's video would be so clear, because today's video I have discussed as a review. Now let's see the second example. Next example, the sequence of function gnx equal to x over 1 plus nx, where x lies between open interval 0 1. At first I will see what is the pointwise convergent of this sequence of function. For this, limit n tends to infinity x over 1 plus nx, which is equal to limit n tends to infinity 1 over x plus n, and this is lies between x belongs to open interval 0 1. Okay, and put this limit, then this would be nothing but this is actually 0. That means this sequence of function converges to gx equal to 0 function. and this convergence is actually pointwise convergence. Okay. Now I will say, is this convergence is uniform convergence? Here also I will use the definition of uniform convergence. Absolute value of gnx minus gx, we have to check this is less than epsilon for each epsilon, and this is true for all n greater than equal to capital N and for all x belongs to open interval 0, 1. We have to check this relation. Now put the value. Here gnx means x over 1 plus nx and gx means obviously 0. That means we have to check this is less than epsilon. Now we can write this as 1 over x plus n, okay, and obviously this inequality, this is obviously always less than 1 over n, and by Archimedean property we can tell 1 over n always less than epsilon, and this is true obviously for all n greater than equal to capital N, and this does not depend on any point. So obviously this is true for all x belongs to open interval 0, 1. That means our proof has done. Here I have got absolute value of gnx minus gx less than epsilon, and this is true for all capital N greater than equal to big value n and for all x belongs to open interval 0, 1. Oh, this function is uniformly convergent on the open interval 0, 1. Have you understood this concept? How we have to check any sequence of function be uniform convergent or not? Okay. Oh well. Now I will discuss one different type of sequence of function. If nx equal to n to the power cx times 1 minus x square to the power n, and this sequence of function is defined for all x when n greater than equal to 1. I will prove is this sequence of function is uniform convergent. But here notice, here there exists one parameter c. So here I will prove the sequence of function converges pointwise on the closed interval 0, 1 for every real value c, but determine those c for which this sequence of function converges uniformly on the interval closed 0, 1. Means we have to find different value of c for which the sequence of function be uniform convergent. To define uniform convergence of this sequence of function, here I will use the second definition of uniform convergence of sequence of function. I will use MN test. Is a sequence of function converges uniformly if and only limit n tends to infinity supremum x belongs to E, absolute value of fnx minus fx equal to 0. That means supremum x belongs to E, absolute value of fnx minus fx tends to 0 as n tends to infinity. Here I will use this definition. For this, if you just recall this function, fnx equal to x to the power n times 1 minus x to the power n. Here I will at first see the graph of this sequence. Here the graph would be such type. This is f1x, which is x times 1 minus x. f2x would be x squared times 1 minus x. This is f2. This is f3, x cube times 1 minus x cube. And this is capital fnx. And notice this all fnx converges to 0. Because fn1 equal to 0. Similarly, fn0 equal to 0. This is true. And for all x belongs to open interval 0, 1, all fn tends to, notice the graph, 0. That means this sequence of function fnx converges pointwise to the function fx equal to 0. Now we will prove, is this convergence is uniform? For this, I will use this test. Since here we have to find supremum x belongs to E fnx minus fx tends to 0 as n tends to infinity. Here fnx minus fx means obviously fx equal to 0. That means put the value, then this would be x to the power n times 1 minus x to the power n. And this is actually, this value is called this as Hn. And to find the maximum, we have to find the derivative, and the derivative would be n times x to the power n minus 1 minus 2n x to the power 2n minus 1. And to find the maximum, n prime x would be 0, and this value would be equal to 0. And since x not equal to 0, obviously 1 minus 2 x to the power n would be 0. That implies x to the power n equal to half. That means the maximum value would be the maximum value of this absolute value would be here x to the power n, and this value is half, and here also put the value, here also half times half, this is equal to 1 over 4. Okay, that means in this sequence of function has a, notice the graph, notice every function, and this is the large fnx, every function has a maximum at the point y equal to 1 over 4. This is nice observation. Have you understood the graph? Okay. And one nice interesting observation, notice, is here each fnx has a maximum at the point y equal to 1 over 4. This is true. But this maximum value actually tends to 1. Okay? Oh, well. Means our proof, supremum x belongs to E, absolute value of fnx minus fx tends to 0. This is not true. This is tends to actually 1. So, by this formula, we can tell this sequence of function does not converges uniformly. Have you understood? Have you understood this graph and this method? If you clearly understand this process, then you will find this value C easily. Mathematically, this would be such type. Here, we have to find this Hn tends to 0 for uniform convergence. If we consider, that means, and Hn mean obviously absolute value of fnx minus fx. That means by epsilon delta definition would be such type. If you consider epsilon equal to 1 over 10, then here the Hn mean x to the power n times 1 over 1 minus xn. This value would be less than 1 over epsilon, means 1 over 10, and this is true for all n greater than equal to capital N, and for all x belongs to open interval, close interval 0, 1. But I have got supremum of this value is actually 1 over 4, and 1 over 4 less than 1 over 10, this is not possible. So, this sequence of function not be uniform convergent. I hope my all viewers have understood all process. This question is same like this type of question. I hope my all viewers will evaluate this question on self. At first try to on self, then see my solution. Let's see the solution. Here fn x equal to n to the power cx times 1 minus x square to the power n, and notice obviously fn0 equal to 0 and fn1 equal to 0, and for all x belongs to open interval 0 1, since consider 1 minus x square equal to smaller, then the sequence of function fnx would be n to the power c x times r to the power n, and since x belongs to open interval 0 1, so this term obviously less than 1 for all x belongs to open interval 0 1. That means limit n tends to infinity, fnx tends to 0 also when for all x belongs to open interval 0 1. That means the sequence of function fnx converges to the 0 function. Have you understood this concept? Now I will see, is this convergence is uniform? For this, use the Mn test. Now we will use the Mn test. Fnx equal to 0, then Fn prime x would be obviously n to the power c times 1 minus x square to n to the power n minus n to the power c 2n x square times 1 minus x square to the power n minus 1, and from this expression this imply n to the power c 1 minus x to the power x square to the power n minus 1 times 2n minus 1. If we common this part, then this would be 1 over 2n minus 1 minus x square, and since x not equal to 0, so when fn prime x equal to 0, then that imply x equal to square root of 1 over 2n minus 1. That means this sequence of function has a maximum at the point x equal to 1 over square root of 2n minus 1. Have you understood this process? Now, since this sequence of function has a maximum at the point, so we have to check now Mn. Mn means supremum x belongs to closed 0 1, fnx minus fx, and obviously where the value of fx is 0, that means this value would be supremum x belongs to closed interval 0 1, fnx means n to the power c x times 1 minus x square to the power n. Okay. Now since this sequence of function has a maximum at this point, so just put the value. This would be n to the power c times 1 over square root of 2n minus 1 times 1 minus x square means 1 over square root of 2n minus 1, here would be n, and we can write this as n to the power c minus half, and this means square root of n over 2n minus 1 times 1 minus 1 over 2n minus 1 to the power n. Have you understood? That means here this limit of Mn depends on this c. When c greater than half, then obviously this Mn tends to infinity as n tends to infinity. Okay? And when c less than half, when the value of c less than half, then this Mn tends to 0 as n tends to infinity. Okay? And when C equal to half, just calculate this Mn would be 1 over square root of 2e. So, this Mn only tends to 0 when only C less than half. That means when C less than half, then this sequence of function be uniform convergent. That means for all value of C, the sequence of function be pointwise convergent, but only C less than half, the sequence of function be uniform convergent. Have you understood? I hope my all viewers have understood this process easily. Today I will stop here. In my next video, I will discuss more question about sequence of function. Okay? See you soon. Stay safe and stay positive always. And don't forget to subscribe my channel for more videos. Thank you so much.